Hey everybody, today we will do another problem. Actually, it's going to be another topic. Um, well, I would say new, I guess, new lecture series. So it is going to be it's called signals and systems. So it is called signals and systems, right? So and I want to be a kind of just give a brief introduction what signals and systems is. Signals and systems, right? A signal is basically some type of output, right? Given by an input, right? So you need an input to create an output, obviously. And that signal can be a waveform, right? For electrical engineering, can be a voltage signal, a current signal, and but it's so it is a signal input into a system, and that system will generate that output, right? And it is important to understand this concept because electrical engineers need to understand the output and the input of a system, right? So, so, so it's a very important topic. However, is kind of deep concept to understand, right? So what a signal does is produces, like I said, so a signal is an output produced by an input, right? So how do we represent that? Well, we represent that as y of n, right? Right? Y of n, right? Right? And then this is an input, and it's going through a system, right? So this is the system, right? The box. The box is just a system, right? System, right? This can be what? Can be this can be a signal processing, an amplifier, right? You take a voice in a microphone, you talk, right? Obviously, in the microphone, that is an input, right? So the voice goes to the process, right? You go to a wire or wireless microphone, right? It goes to a wireless microphone, and that wireless microphone has a box, has a receiver, right? So you transmit a voice, it goes to a wireless to a receiver, right? It's going to be a little box over there with the two antennas on it to receive a signal, right? Now, this goes through a process, right? It goes through an amplification. In that amplification, the output of that amplified voice can be a signal, right? Um, okay, so right here, right? Now, this is input. This is input, right? And this is obviously output. So the signal goes in, right? In signal processing, for example, you get a signal coming in, it gets processed in this, right, system, This system can contain a bunch of filters on it, and then those filters are filtering the noise of that voice and comes out a clean signal on the other side, right? An example would be um, a voice that it gets transmitted through a phone, right? A wireless phone, right? So it goes, somebody called me, I answer the phone, and then I talk, obviously, right? If I answer, I have to talk, right? I gotta say at least hello, right? That voice is an input in the signal. It goes to a process, right? Nowadays, the phones use discrete signal. Okay, so it's analog when it first goes into the system. The phone has an antenna, internal antenna on it. And that internal antenna passes the signal through the air by discrete signals. In other words, zeros and ones. Discrete signals, right? The discrete signal goes on to another end, right? Where the other person answers the phone, right? When he or she answers the phone at the other end, that get reversed. That signal go from discrete signal to an analog signal. So the person on the other side can also understand, right? Because human beings, we don't understand sound in zeros and ones. We don't. Human beings only are capable to understand analog signals, right? So therefore, the signal is going to arrive in discrete signal, but it's going to go through a process to an analog signal so the other person can understand, right? So this concept is used in different areas, right? So the system comes in, right? And it's an input, and then we get an output. Obviously, if I have a y of n over here as an input, over here I'm going to have something else called x of n. Okay, so that basically, again, can be a lot. This concept can be in signal processing. That signal can be images, right? When I look at the TV, I look at a bunch of images on the TV, and I am able to see the person talking on Fox News. Remember Fox News, right? Fox. Yeah, so you guys know that's why this channel called Conservative Engineering Academy for a reason, right? And also Fox News is becoming almost like fake news. It's a good thing that they already have the first letter on it, right? Fake. So Fox News is becoming fake news now, but in order to see the news reporters on the other side, this image has to be converted. It has to be, in other words, it's hundreds and thousands and probably millions of pixels compressed in an image so I can actually see it, right? So this can be done in image processing, signal processing. The same concept is pretty much being used, right? Now with a brief introduction, right, of the signals and systems, we have two different types. We have discrete time signals right? Discrete time. So we have analog signals. We have analog signals, and we have discrete time signals. We have discrete time signals, right? So right. So also we have actually, you know what? Let me just change this because I think a better word for it is continuous time signal, which is analog signal, but just use continuous. Right. So we have the different signals, right? So like I was saying, the analog signal would be considered as continuous time signal. The script signal would be zeros and ones. I understand this type of signal. If anything is broken, like my broken English, right? If somebody like doesn't pronounce the word in a continuous, right? It's kind of hard for me to understand. So why? Why I'm trying to say that, right? So this is right. So if I go like this, you can see that this graph right here, this is t, right? This is whatever, right? So this is yeah. So this is t, this is t, this is x. This is x of t. Right. So this, right? So right here is time, right? So time has to be continuous. You don't see anything broken here, right? You don't. But if I have something like this, I have something like this. See that? And then I have you can see that right here, and I can understand. I'm not going to be able to understand the type of signal. Why? Because I got gaps in between. This is the script. This is time signal, right? Computers understand this. I understand this. Continuous. continuous time, right? Continuous time signal, and also discrete time signal, right? So right here, still the same thing. We have x of n, and we have a t, right? You can say x of t or whatever, but again, I'm going to do the rest. This is just the introduction, but in the real function mathematically, right? So okay, so this is the output, which is represented by this, right? And this is the input, right? So this is the input. Input will be anything, that goes over here will get an output, right? So now, okay, so now let's talk about some signals that in this case, right? So it's going to be, so let me just, but I want you to kind of try to grasp the idea between discrete time signal and continuous time signal. You can see that this graph is continuous, right? At every point. Okay, now let's do this called time domain model of systems. So it's called time domain models of systems. Right, so time domain. Why is it called time domain? Because it's based on time, right? We have, eventually, probably we'll do some videos, probably, I say probably because, I just want to be honest with you, I am not a YouTuber full time. So eventually, probably we'll look at something in the frequency domain. Right now, we only have what is called, in this beginning, right, time domain, right? That's why it's called time domain models, right? Now, with that being said, so there is a specific input and output representation of a system. In this case, right? In this case, I am using this book, by the way. Not the best book. And if the author see this video, you probably got to do a better job in this book, because this book is not an easy book to understand. Right? It's called Fundamental of Signals and Systems using Web and MATLAB. Right? So a lot of this is not the best book, but anyway. So I'm not here to recommend this book anyway. So I'm really, okay. But anyway, so technically, what this is it says that. Okay, so it goes like this. So a certain input, y, and n, a small n, right? It goes like this. It goes 1 over capital N, and it goes with the open bracket like that, and x, and then a small bracket and a small n here, right? And then it goes plus x again, right? But then over here I get n minus 1 plus x again, n minus 2, and then it goes plus it goes to x xn minus capital N plus 1, right? Plus 1, close the bracket, and close the big bracket. Okay, now, they say that this can be reduced to the following, right? So it can be reduced to y of n input, and it's going to be of the summation of, right? So it's going to be n minus 1, the summation of I, in each of the i's, starting from 0, and it goes capital 1, right? Again, 1, then over capital N, and then x, right? So right here, it's going to be n minus I, right? So, with that being said, we are going to analyze. We're going to analyze a specific type of system that is called exponential weighted moving average filter. So it's called exponential it's called exponential, right? So yeah, so exponential weighted so there's moving average filter. Right? Filter keywords. Filter. Yeah. So a lot of filters are used in engineering. Many type of filters. Filter for filter noise of communication system. Filter for electricity when you have a bunch of non-linear loads, right? Like computers, like big printers, like VFDs, right? Variable frequency drives. Those types of systems, they generate a lot of noise. Why? Because instead of having a signal like this, they will have something like this. So it's going to be something similar, but it's going to make a bunch of loop, or make maybe a zigzags like this, right? And then he will create another, right? Because you got nonlinear loads, you got this bunch of waves, to simulate the sinusoidal wave, and then you create noises created. Because again, because a bunch of switching systems like transistors and capacitors and inductors all put together is going to create a noisy signal. So therefore, we need some type of filter to filter that. Well, to filter that noise up. And how we do that? Well, we do it by creating bandpass filters or other filters. Creating different filters, right? Different configurations. You have low pass filter, you have a band pass filter. So you have a high pass filter, bunch of different filters. But in this case, we will analyze this, right? This type of filter, right? Exponential weighted moving average filter. Okay, so with that being said, we need to modify this formula a little bit. This formula has to be modified a little bit. And then that formula is going to be like this. So it's going to be y of small n, right? And that is going to be equal to capital N is equal to 1. And again, it's going to be the summation of that. And over here, we'll have a W sub I, and it's going to be X. And then it's going to be and then it's going to be n minus 1, right? So, but again, now we have to modify the formula again, right? And then we will do that y of n equals capital N, right? Starting from 1, and then it goes to A, right? A and parenthesis B to the I, exponential. That's why it's called an exponential weighted filter. All right, so it's A, and then B to the exponential I. Let's put it right here. All right, to the exponential I, and then that is going to be an X again, and that is going to be another bracket, square bracket. It's going to be N minus I, close those brackets, and close the parentheses. All right, so this is the one that we will be using to analyze the system, right? Now, we need to find A, right? We need to find A. So in order to analyze this, we need a formula for A, which is formula for A is, so A equal 1 minus B over 1 minus B to the capital N. Right. So capital N is a number. It's a number that is like repeated. It's not a repeated number, but it's like an event, like an event number, like how many times this event happened, right? You can look at it. You can look at the end that way. Now, This is the thing, right? So right here, let's say for example that we have that okay, so B, we gotta be careful with this because B is not any value. So B has to be sitting between. So B, this B right here has to be right. So notice that start of 1 minus B and 1 minus B to the n power, right? So in other words, it's going to be 0. B is going to be 0. It's going to be less than 0, greater than 0, right? But less than 1, right? So B, again, B is greater than 0, but less than 1, right? So now, with that, we can actually start doing something, right? So let's say, for example, that we start at B is equal to 0.5, right? So does that satisfy it? Yes, it's greater than 0, but it's less than 1, so 0.5 will work, right? So now let's do, okay, so now let's say that you have an event that I, right? So I go from 1, right? 0 to 2, right? So let's say that I go from I go from 0, 1, 2, dot. And then we have the letter, which is like whatever n happened at n time, right? And then we have n minus 1. So at that point, right? So I is an initial point, and n is what is represented that interval in between, right? That interval or whatever, like events that happen, right? In this case, how many times it happened? Well, it happened 0, 1, and 2, right? So in other words, it happened 3 times, right? So now we can assume that capital N, in this case, is equal to 3. Now, if I look at this, I have to find my A. Once I find that A in this event, because I'm taking the largest number of that, which is going to be 3. So in other words, it's going to be like this. So it's going to be A is going to be equal to, we know that B is 0.5, so it's going to be 1, right? Minus 0.5 divided by, what is B? So B is 0.5, so 1 minus 0.5 to the what power? To the third power. Right. So when I get that, I get that number is equal to it's equal to 0.751. So A is equal to 0.571. Yeah, sorry, 0.571, right? That's what it is, right? Now having this, right, we need to analyze something else. Look at the formula. The formula has to be kind of in this form. When some type of number, right? So now, as you can see, that A is equal to these x values, right? To these x values, right? So in other words, x is equal to A, right? So it's a so now that's kind of representing that. Now, if you look at this, what number will make this number just x of n. Now, if you look at that, this is going to be when b is equal to 0. When b is equal to 0, right? So when b is equal to 0, that is going to be equal to x of n, right? So in other words, if b is equal to 0, a is equal to 1. Well, it doesn't really matter, right? So, because the thing is that this is going to be based on this formula, right? So, based on this, if a is equal to 0, if b is equal to 0, right? So, in other words, if b is equal to 0, right, that's the only way that can happen is that b is equal to 0. If b is equal to 1, then any number to the 0 power is equal to 1. So the only event that can happen is that b is equal to 0. If b is equal to 0, then a times b is going to be 0, which is just going to be left with that, right? Now, if you think about this, right? So if a is equal to 0, if b equals 0, and if b is equal to 0, a equal to 1, then a times b is equal to x of n. Okay, so if that is the case, the first number is going to be simply that number times that, right? So, okay, okay, so let me go back to what I said before, right? About this. So a is the only number. X is going to be stayed, right? So a is going to be making this. This is still like a variable, right? Multiplying that signal, right? It's an output. So I kind of want to go ahead and correct myself over there that a does not equal to x. So x is representing the output of the signal, right? So now what? But a will be changing, right? A will be changing accordingly, right? So now if I know that the only way that x is equal to n in this case, right? Because we are getting the weighted values, right? So we getting this is our thing to consider, that we have W not W0, we have W1, we have W2, right? In this case, we only getting the weighted value of this 3 times. But technically, this is the weighted value, right? This AB, right? Now, if you think about it, now look at this. So now, if I get this by using this, right? So the first value is going to be y of capital N, lowercase n, right? It's going to be equal to what? It's going to be equal to, in the first one, right? So it's starting at 1, right? It's starting at 1. In this case, if I plug in 1 in that, it's going to be simply 1, right? So this term is gone. So 1 divided by 1, just going to go ahead and stay. But in this case, because I am starting at 1, right? It doesn't really matter, right? That went away. So now what I'm counting is that one. So then I forgot a 9 here. 0, right? So now what I will do is put the weighted value that I need in there. So what is the weighted value for the first one? For the first one, right? For the first one, it's simply that one, right? Doesn't really matter because it's that one. So it's going to be 5. It's going to be 0.571, and it's going to be x, and it's going to be n, right? That's the first value, right? Plus. For the plus, I have to consider, right? I have to consider that for the plus, what is the second, right? The second value, right? So we didn't have that one, right? Now, so in the next case, we're going to consider that we are going to consider that 2, right? So now B is 0.5, right? So we know that A in this case is that, right? So now we use the value of A, so we say that W2, right, is equal to A times B, right? Now, if you look at this, so A times B to what? To the first to the 1 power, right? Which doesn't matter, right here. A times B to the 1 power. So if I do W2, so W2, right? No, actually W1, because this the first one we calculated was 0. So this is 1, right? And then I do 0.571 times 0.5 squared, right? So times 5, right, to the power of 1. Which that is going to be what? Is going to be like a point something, 0.88, 0.286, 0.286, right? So 0.286, right? That's the first value. So I'm coming over here, okay? So, and I say 0.286, right? So I need to kind of move this because I'm running out of room over here. So okay. So now it's n, right? But what value I'm calculating, right? It's going to be 1, right? That is 1. Right. Now, so let's do the next. So let's do the next value. So if I take now it's going to be W2. Actually, let me do it right here because that way I have to use this as space. So W2, right? That was W1, now it's W2, and it's going to be equal to AB squared, right? So AB squared. Now, if you think about it, is the number going to be AB squared, right? So now I am going to plug in so that number, right? It's going to be equal to W2 is going to be equal to 0.75 0.7571 times 0.5 squared. Take that number. So then it's going to be equal to 0.5. It's going to be equal to W2 is going to be equal to 0.143. 143, right? So 143, right? That is the next value. So now I take that value, right? And I do 0.43 x, right? And it's going to be n, but it's going to be now, it's going to be a minus 2. Right. So now, as you can see, now you can see how the system is changing, right? Now you think about it. You can think about this. So you can think about it as the amplitude of the system. So you can think about it as the amplitude of the system, right? So now you can see that this system is behaving differently. Now, eventually we will do some shifting, and if you use a convolution, right, for analyzing this type of signals, you can actually we will use the same, not the same, but similar techniques to analyze this type of systems, right? Well, it's going to be in the convolution type, but it's going to be so we will have like shifting left to right depending on the value of t and the value of tau, right? So because tau is going to be a dynamic variable, but right now I don't want to get into it, and I want to get into it because I want to just do this, right? And this, like I said, this is called an exponentially weighted moving average filter, right? So therefore, this is basically the introduction of the signals and systems. So, but again, in the next video, we probably will do some time because this is like in the script time. You can see it. But it's still in the time domain, right? But it is the script time. As you can see that in this case, so like I say, the representation, this is like a continuous, right? Pure, time domain, right? So it's going to be a continuous time domain. In other words, continuous time, right? Signal, I will say, and the other one is going to be a script. But it's another thing to analyze too. Like, okay, so let's say, for example, so you can make right like that. Now, what systems do? They try to do this, right? Make a square like that. right? Or the system also will do this. Actually, normally that's what they do, right? And then it comes over here, simulate another wave, and right. So you can see this in a square wave, but inside the square wave, it is a pure sinusoidal wave. Now, the system is trying to output the sinusoidal wave, but it has noise on it, right? That's why we use filters to filter out the noise, right? And a lot of systems like microcontrollers, BFDs, they output at a square wave, but what they're trying to do, they're trying to simulate, especially BFDs, a sinusoidal wave. In other words, so for the motor to understand, so the motor only take AC power, right? So the BFD is putting this signal, right? Is processing this signal, and the BFD has so the signal goes into AC, right? And then it goes through a DC bus, and then after it goes to the DC bus, has a rectifier to rectify the signal to simulate the signal, right? Into to simulate the signal back from DC. So it goes AC, DC, and then after DC, it goes to a rectifier to simulate AC back again. But that AC signal is going through a pulse with modulation. A pulse with modulation. So that's how BFDs work, right? But anyway, that's I just want to just give a quick example how we can use signals and systems in different areas in electrical and high power electronics engineering. Thank you for watching, and I will see you in the next video.